So for these parametric equations, we have x equals 3 plus 2 cosine t and y equals negative 1 plus 3 sine t. I'm actually going to work this problem in reverse of the others. For the other two problems we did, I made an x, y, t chart. We drew the graph, and then what we did was actually eliminate the parameter. And I'm going to eliminate the parameter first because frankly it's easier that way. But what you can actually do when you see stuff like this is not get intimidated by the sine or the cosine. But what I'm going to do is actually solve for each of those. So if I have x equals 3 plus 2 cosine t, I'm going to solve for the cosine t. So to do that, I will have my x, I'll subtract the 3 and then divide by 2. So I have x minus 3 divided by 2 equals cosine of t. My other equation was y equals negative 1 plus 3 sine t. And I'm going to solve for the sine t. So I'll add 1 and then divide by 3. So y plus 1 divided by 3 equals sine of t. Now, the reason we did that is I'm actually going to use one of the Pythagorean identities with trigonometric functions to figure out what the equation is. I want to get rid of the sines and the cosines and get x's and y's in. Or rather, really, I want to get rid of the t's, but we have this Pythagorean identity that says sine squared, and I'll use t, plus cosine squared t equals 1. If you imagine on the unit circle, these are your y values squared, these are your cosine values squared. This is the hypotenuse. This is the height, the x value, the hypotenuse squared. So what this gives me is the ability to get rid of the sines, the cosines, and the t's, because I can very simply come over here. If this is sine squared t, I come over to this, and I know that that means y plus 1 divided by 3 squared plus, look at my cosine t value, x minus 3 divided by 2 squared equals 1. And I have an equation with no t's in it that's true. So that's a sneaky way to get rid of all of your t's. So you may or may not have seen this equation in this form. It might be more familiar to you in this form, y plus 1 squared divided by 9 plus x minus 3 squared divided by 4 equals 1. And this should look familiar. It's one of our conic sections. It's not a circle because the numbers are not the same. It's not a hyperbola because there's no negative on either of these. It's not a parabola because both the x's and the y's are squared, and what's left is it is an ellipse. So it's a lot like a circle in the fact that both coefficients are positive, but we have a different x radius and a different y radius. The circle just has the same radius for both. So you could write these in either order. What I know from this is where my ellipse is centered, which is at, this has been shifted 3 to the right and 1 down. So it's centered there. I know my x radius. It's right here, it's a 2. If you saw it in this form, you should have known to take the square root, so it's a 2. And then my y radius for my ellipse is going to be 3. So I can graph it. I can go 3 to the right and 1 down, put my center on. Now my x radius is 2, so I'm going to go 2 either direction from my center. My y radius is 3. So up 1, 2, 3, and down 3. And I have my ellipse, or my approximation of a drawing of an ellipse. The only thing I don't really know is direction. Which way, if I had a particle on this, which way is it traveling? Is it traveling clockwise or counterclockwise? And you can get that fairly quickly by plugging in some values into your x and y, which we could have started with. Now, when you're working with sine and cosine, don't make your life too hard. Pick easy values. So I could plug in any radian I want from the unit circle, but I'm going to stick with, let's say, 0 and pi over 2. So these are my t values. And I only really need 2 because I just need to know which direction. And pi over 2 is definitely greater than 0. So I have my x and my y. So if t equals 0, I know that cosine of 0 is 1, times 2 is 2, plus 3 is 5. At 0, sine is 0, so that just gives us a y value of negative 1. So we're at 5, negative 1, right here. This is my start. For my next point, I'm choosing t equals pi over 2. Cosine of pi over 2 is 0, so that cancels out this term and I'm left with 3. Sine of pi over 2 is 1, times 3 is 3, and then you add to that a negative 1 and you have 2. So 3 comma 2 would be my next point. So to the right 3 and up 2. And I can tell from that that I'm going this direction. I'm going counterclockwise.